making a video, draft science video. Just thought I'd go over a couple of things of interest to me, anyway. Yeah, lights blinking a little. Anyway, not good. Bad timing. Yeah, the storm didn't, not nearly as bad as expected, so feeling much better about the weather anyway, and my imminent doom. So I probably won't get killed by the snow. But Piero might. You know, he's in Maine. He might get a big ton of it. Anyway, so yeah, I'll read some comments, but I want to just do an overview thing real quick, like that ever happens. So I just want to explain again how this, this all started like a few years ago, this quantum mechanics stuff. I was just never too happy with this two-slit explanation of photons that can read our minds and stuff. So I started thinking about physics and some sort of different model, because the standard model, they call it the standard, it's not too good a model. Very complicated, very, very messy. And I just figured reality's got to be simpler than that. And then, so those little things, you run into relativity and all this stuff, and that doesn't sound right either, this whole, how does light transmitted between, so I'll go into that a little bit. And, different things, it just doesn't make any sense, but you're saying, no, the engine of the atoms just can't, there's got to be some other explanation. I guess my brain was just saying, it just doesn't sound right. The empty space doing something. So anyway, so what occurred to me was just this whole E equals mc squared thing, and just the intuitive logic. I mean, I hate to say that, but just the make senseness of it, to say, well, what is happening here is that photons go in and photons come out. So why don't we just say that the whole thing is made out of photons? That atoms are batteries. Atoms are containers that hold a lot of photons. And it sort of made sense because you think about nuclear bombs and all that kind of stuff, and the E equals mc squared, the c squared, speed of light squared, really big number, lots of little tiny things in there. So that all made kind of sense to say, yeah, maybe atoms are, they're not solar systems, but they're made out of bits, and the bits are photons. So that led me to, once I ran into gravity, you think of real world gravity, so yeah, first I was dealing with it like, what is gravity for us? But then, if you start to think about the atom and you start thinking of it made out of these little tiny fish, you start thinking about there's a force that's holding all that stuff together too, and why wouldn't it be the same force? It's the same force, just magnitudes of difference in terms of scale. And so I like that idea, and so that's where this sort of the origin of this thought of pixelating everything, turning everything into pixels, and saying that no, there's a discrete bit at it. It's got there's a simple function to the universe, and so it also had to do with the idea that I've, even before I thought about this, I had thought about this idea of the universe being a checkerboard, and stuff is just moving, on a like a clock speed. Everything just moves one space, and that really does solve the problem of momentum and different things in terms of light not having any. Because it's just a refresh of position. But anyways, so that I'm not so glued to anymore, and it doesn't really format well to restrict photons in terms of directionality. I mean, a checkerboard or a cubic universe would have the problem of diagonal spaces being longer distance, and that just gets too messy. So I can live without it. I don't need it. Space is nothing, and photons are something, and that's what the universe is. There's nothing, and then there's photons. Nothing else. So it's all just made of photons caught in patterns, and that sort of went with the whole model of the atom, the whole idea that it's stuff moving about very quickly and all kinds of stuff going on in there, and it's just photons doing all that stuff because they're trapped in circles. So that whole idea of just being trapped in a circle, and the fact that that just solves the whole, well, there's your speed of light, but it's not going anywhere, that sort of makes matter. So matter's a bunch of photons caught in patterns, or you could just say all circles, who cares? And they don't go anywhere, but they're still in the universe, and they're still being affected by other things. So anyway, so, you know, the gravity thing is the thing that will be the, you know, explaining how the atoms are held together. So I'll try to get to that. Maybe I'll do that real quick right now, and then I'll get to other stuff after that. But what I'm thinking now, this is just a current thought called draft science. I'm just playing around with some of this stuff now. These aren't as serious as the other videos in terms of, you know, saying this is a hard truth. But I'm figuring that, you know, gravity is this idea of an electron and a nucleus, you know, and the electron goes around, and that, you know, it could be held in place by a gravity, you know, these gravitons that occasionally knock it into place or keep trying to force it in just because of the shadowing effect. So it would be the same as real gravity. But the catch here is that electrons don't fall in to atomic nucleuses pretty much ever, as far as we know, right? You can sometimes force something into an atomic nucleus and break it, causing a chain reaction, nuclear bomb kind of thing. But it's a pretty stable arrangement. So what I'm thinking is that this is the origins of, this is where magnetism starts, is in this relationship between the nucleus of an atom and the electron. And that what is happening is that they are, that the force being applied is the origins of magnetism, and that they are filtering different gravities, you know, A-B argument again. And so although there's a force from the external world pushing it, trying to condense it into a smaller bit, there's also another force being created that's creating a higher pressure between these two objects, so they can't get any closer to each other. So it's basically forcing the separation of the electron from the neutron. I mean the nucleus of protons and neutrons and quarks, whatever else you want to shove in there. And so it's the origin of magnetism is what's holding, preventing the complete collapse of the atom into a single chunk of something. We'd call it a chunk, but it wouldn't be a chunk, obviously. But anyway, and that would sort of fit with what we see in magnetism, which is the idea of you know, pattern forms in terms of the radiations, how the radiation. So see, the trick is when you see that you know, when you see a magnet and you see those typical lines of force, the trick to that is that those are sort of artificial, because you only see them because you're basically aligning other magnets with the original magnet. It has to be a magnetic substance that you use to make to reveal those lines, and that you usually also have to kind of force, the tendency will be for this, whatever's in those lines to end up migrating into the magnet if given time, and if not being blocked by a piece of paper or something. The idea is you put a piece of paper in front of it, and it's a little different because those magnets really do want to go to the big magnet. You know, that's what they're really trying to do, and you're stopping them with a piece of paper and forcing them into a position that isn't their natural position. So it's like those lines don't really exist as lines. They're where the force changes, where the amount of photons pushing and pulling changes, and so they are aligned on those lines because those lines are dividers. But it's not really a line. It's just a separation, you could argue, between layers of density of these magnetons or gravitons or whatever you want to call them. So yeah, I am going to use some words that I'm going to make up. I mean, one of them is going to be atomic metabolism, which I think is a great way to think about atoms, and directional momentum or directional information. You know, that'll be another term I'm probably going to use a lot because that has to do with this whole kinetic thing and the fact that there's, from the point of view of energy, which is the photons, from the point of view of energy in the universe, there's no transfer of energy. There's just transfer of direction. They can't transfer energy. They only have two components of energy, which is their mass, their substance, and their velocity. And they can't give away either one of those things. You can't destroy a photon. Alright. Yes, that's enough. I'll read some of this. So I might as well do Pyrrho first. What the hell since here? You complain about being slandered, but then you don't care about any slander you sling. It's not coherent. Well, again, I don't think I'm slandering anybody. You're I think, totally exaggerating that, you know, I'm saying what I've said and who I've said it to. So, you're not quoting me, and you're still not quoting me in any kind of context. And the only people I've been really aggressive about calling liars have been really liars. I mean, there's no excuse for it. I mean, experiments that haven't been done, and you're going to, you know, that's bullshit physics. What I've said about Feynman, again, what the fuck? Oh, it's birds. Probably. It better be. Frankly, you generally say it's okay for you to slander people that are wrong. Call what you think are mistakes, lies, and so on. Well, you know, you're saying I think they're mistakes. You won't even admit they're mistakes. And so what is that? You know, again, I can say that there's no point in Feynman giving lectures when he's not explaining what he knows to be the truth. You know, I don't know. And like I said, if you know something's not the truth, and you're explaining it as if it is the truth, and you don't say, wait a minute, this is just, I'm just using a metaphor here. This isn't how it actually happens. You know, I'm sorry, there's words for that, and they're not good words. Eventually because they are wrong. Evidently because they are wrong. Yeah, and they're wrong in a way that has, in my opinion, it's a substantial mistake, okay? I think physics has been retarded for 100 years because people drew assumptions based on tiny bits of information, and they drew conclusions, and the conclusions were hard conclusions. They've been talking about this wave-particle duality as if it's a reality. They don't have substantial evidence of any kind of wave. They don't even have a way of describing this wave as any kind of coherent description. We're supposed to visualize a wave that doesn't really wave out, and that it doesn't really go anywhere, and it just, I mean, it just doesn't make any sense. That somehow a photon traveling billions of miles through space has waved out through the whole universe because it's had so much time to do it, that somehow the wave would be reaching across zillions of miles and parsecs of space, and that somehow it's going to do a calculation of all those interactions it's had through the entire universe before it decides to crash in my eyeball. I mean, it just doesn't make any sense. Anyway, for my part, I don't think you have a theory that at all can stand up to things like disproving there really is time and space distortion via gravity. Well, again, I don't have to disprove it, because I don't think it's a terribly well proven theory. All I have to do is explain some other process and explain why it's a better explanation, why it fits the experimental data better, why it answers the question of why and how better. And that's what I intend to do. And again, like I said, you can be a useful participant in that effort, or a useless one. And I'm just saying, this is all useless. Even this, I don't think you can. I don't think I don't. But this isn't an argument of any kind. This is totally unhelpful. If you have some particular factual experiment that you want to say, okay, here's an experiment. Try to explain how your theory would fit the results of this experiment, I might be willing to do that. But some of these experiments, I'm not going to worry about experiments where they're shooting photons underneath Fiji and they say they can entangle them and then bring them back and ask the photon whether it had a good time. I mean, I'm not gonna waste my time on experiments like that, and I'm certainly not going to analyze the preposterously obtuse data from accelerator experiments and stuff, because I don't think any of that is a good photograph. It's so low resolution photograph that you might as well say, look, here's a picture of a ghost, and say that ghosts must exist because look, we have a zero resolution photograph of one. So anyway, so coax guy, I'm sorry that I came off as rude and it's not my intention. Well, I don't know. I'll see if that's a viable argument, but frankly, I mean, I don't know how you can really do some of the things these people do and say, it's not my intention. It seems like it's pretty much your intention. If the universe happens to be eternal, then no heat death is possible. Well, it happens to be eternal through what process? All I'm arguing is that there was one, in my opinion, okay, there was a way that the universe could possibly, do the rebounding thing. And that would be that if all the mass started smashing into each other and created a super gigantic black hole, so to speak, or a hugely dense part of the universe, that it might be able to create enough gravity to pull, that a light beam way far away would just slowly start to bend a little bit and a little bit and a little bit, and it would bend its way back because of the super strong gravity or something. But that doesn't work for two reasons. First, light's not really bent by gravity. And second, now because we know gravity is here, it's not out there, gravity is going to dissipate, and so there won't be any gravity to bring it back, because gravity is made of something, and the something that would pull the stuff back is not going to exist, and it won't be able to pull anything back because it won't exist. Anyway, how much do you really see? How much do we really see? Some of their functions are just mathematical. I know physical form has been detected, and one wonders whether we can empirically validate some of these small things, mathematical creations. Again, that's your perception, okay? What I'm saying is that a lot of these things are mathematical creations. If you look at the math, and it'll hurt your brain sometimes to try to figure out what exactly these variables are, and what exactly they're comparing, and why exactly they're cubing this, and squaring that, and halving. I mean, they don't give any of those explanations of why there's a relationship between the size of my shoes and how many paint chips are on my ceiling. I mean, sometimes the math is pretty obtuse, and you've got to say to yourself, well, maybe they're just trying to turn everything into a 1 0, and I don't know, and they're just doing it in a very complex way. I mean, some of this stuff just seems like that. I mean, they have actual math where basically the whole formula does all this fancy stuff, and then some other part of the formula just multiplies it by 1 or 0 to negate the result, because they know the result's going to be shit. So they basically have a catch in the formula that will prevent the formula from giving them the wrong answer, in the sense that they know that if it goes a certain direction, the formula is crap, and they might as well negate everything in that part of the formula by just multiplying everything by 0. So I'm just saying, it's not exactly easy to follow along kind of math. But whatever, it doesn't really matter to me. Look, math is a way of seeing things. Okay, it's a kind of radar, it's a kind of vision, and vision is a kind of vision. So I'm just saying you can model something explicitly, or you can model something in numbers. I could show you a vector drawing or photograph, and the vector drawing can look like me, or it can look like a bunch of numbers, mathematical, and require a mathematical formula to decipher. So it's going to need to be deciphered, the numbers. And it's almost like this image is just to the computer a bunch of numbers, but at least the deciphering is very simple, where in a vector rendering, the deciphering would be more complicated, so you could make the amount of numbers smaller because you're doing more calculus based on a formula. So the formula is bigger, that means your information you need to put in can be smaller. these are different ways of seeing something. I'm just saying that from my perspective, I would rather have the picture. I'd rather see the picture than the math. Anyway, pseudoscientist fraud. So, yeah, that doesn't even mean anything. I mean, again, this is useful in how. I mean, you know, it would be a fraud if, like, I did have actual credentials and I was fooling people. I mean, you could almost say that I could accuse, you know, Feynman of being a pseudoscientist when he described Newton's glass experiments incorrectly, because he had credentials, and you expect more from somebody with credentials. But I'm certainly not frauding anyone. I mean, I've totally explained every element of what I'm thinking and why I'm thinking it. There's no fraud. I'm not stealing any money. I'm not stealing anything from anybody. I'm not asking anybody to believe me because I say so. I'm explaining why it makes sense to me. So calling that fraud, I think, is just really stupid. I mean, that just makes you a pseudo-intellectual moron. And who are you again? Twat face. Well, yeah, this cool guy's just, well, whatever the fuck it is. He's just as much an asshole. Space itself is distorted because the Big Bang, fuckhead. Fuckface bitch. Space itself is distorted because of the Big Bang, fuckhead. Space is distorted because of the Big Bang. I mean, I haven't heard of that before. Space isn't really distorted. I mean, the argument is that space reacts to matter, and it would react to matter whether there was a Big Bang or not. Space distorts as a reaction to the existence of mass. But the argument is, why does the space do something, and why does it force other matter to do something based on what some matter over there did? And how is space communicating this information? And there's no mechanism for space to do that, where if you create an actual physical object that does it, then you can explain why there's a cause and an effect, because you can see the strings that connect two things. I can connect the moon to the earth with photonic gravity and explain why the moon moves, the earth moves. I can explain why the two things are connected to each other through that relationship. But to say that space is communicating information from the earth to the moon, that's a little harder to figure out, because how exactly is it communicating this information? Alright, if the Big Bang is true, then you believe the universe just popped into existence without nothing, fuckhead. Well, that's not true either. The universe could have been, you know, you could argue that this is sort of a reoccurring thing that happens in the universe, and you know, there's lots of ways you can explain how the energy could be bounced. It could all just be a bubble, and it bounces off the outside of the bubble. Eventually, all the photons bounce off the outside of the bubble, shoot back into the center again, and start all over again, or something like this. So you can create mechanisms that make it a reoccurring universe. And then you can create thought experiments or ideas where every time the universe expands and contracts, it adds one photon. So you could argue that the universe is zillions of bazillions of bazillions of bazillions of years old, and it's just been adding one photon, you know, each incident. I mean, you can come up with all kinds of crap. It doesn't really matter to me. It's just, you know, I'm more interested in just describing one element of the universe's existence, not its origin process, its birthing process. I'm explaining what it is after it's born, not before it's born. Anyway, he believes everything is made of photons. How convenient that he says change differentiation plus and minus is nothing but a physical difference in how photons spin and shit. Yeah, well, whatever. I'm not too worried about the whole concept of spin. You know, that's just a word they use to describe nothing. Nothing proven. So I'm not sure that photons do any spinning, but it doesn't really matter. It doesn't have anything to do with what I'm arguing about, the fact that kinetically, when it comes to electrons, there's an interaction between photons and electrons that follows a consistent pattern called quantum mechanics. And clearly there would be a relationship between how gravity and electrons would also interact, in the sense that if you think of them as discrete particles and acknowledge that photons have nothing else to exchange but direction. They can't exchange speed and they can't exchange size. So if they can't exchange those two things, they're only left with direction. It's the only thing they can exchange. How convenient. Prove this. Oh, that's right. The proof already there. All we need to do is believe that it's a photonic universe. Well, I mean, I'm just saying all you need to do is start modeling it and saying, does the model explain the phenomenon? And as you start to do that, as I did, you realize that once you do this school of fish thing, then all of a sudden the school of fish, you can make the school of fish explain time dilation. That's a pretty significant thing to be able to explain, you know, just starting off with a mechanical model. And so I'll make that argument one more time, just because, you know, I've said it different ways. It's like tap dancing, and then you go, if you have to move sideways as you're tap dancing. And people, you know, I tried that on somebody and it didn't really work. But when I explained it this way, when I said, if you're walking from your living room to your kitchen, it'll take you a certain amount of time to do that. Now, if I asked you to take a step to the left every third step you take as you walk from the living room to the kitchen, you could sort of understand that it would take you longer to get to the kitchen, because you're taking this extra step sideways every third step. And that's time dilation. That's the atomic metabolism being revealed. And then it also works for this whole relativity of velocity, which I'll go into a little bit later, I think, in terms of what happens in Einstein's thought experiments, in terms of attempting to communicate between something not moving very fast and something moving very, very fast, and what would happen in terms of their perception of each other. Alright. Anger management fucking guy. You know, that's useless. It's all these same these trolly people, so I should just block them. I mean, I'll just say as a warning to people, if you post more than one comment, 2 comments on the same video, yeah, I'm going to block you. I just find this is such asshole behavior. 1, 2, 3, 4, 5, 6 comments on one video. It's just asshole behavior. You can't do better than that, jackass. You can't think before you type something and wait till the video's finished to type something. I mean, it's childish. Haha, you just keep talking shit. Now where is your Nobel Prize? Well, I said in a year. And I don't think I said I'd get the Nobel Prize in a year. I'm just saying that I will eventually get it, because I have done what Einstein spent his whole life trying to do, and I've done it correctly, which is even better. So, what can I say? I'm going to unify it. This is the explanation for our reality, and you can not like it all you want, but it's going to end up being the truth, because it's the truth. Like I said, I would bet most of my organs on it. You have no conception of quantum dynamics or even particle physics, as your role model is a pre-atomic physicist. He's not my role model, Newton. And clearly all I'm saying is Newton was only missing a little bit of that understanding, right? He didn't know that the light had a speed, and he didn't know that you know, gravity happened to be moving at exactly the same speed, which might have given him an indication. I'm just saying that Newton did rather amazing things with rather crude tools, and you can call him a pre-atomic physicist, and it's not really about Newton's physics in the sense of, the argument I'm making is that the real physics, the only physics that matters, is the physics of the photon. It is the machinery, and gravity and momentum and velocity and all the things you see in this big world are being created on that small world. Okay, they're being created in that actual physics, and in that world it's all kinetic and it's all Newton. So anyway, yeah, so I think that's enough of that anyway. There was a couple of okay, I'll do the light thing first, and then I'll do the momentum thing, because that gets a little sloppier, I think. I mean, I'm still not, I'm still trying to come up with the idea. I mean, when we have velocity, there's something that's making us move. I mean, Feynman did, most people just don't even think about it because it just seems like, oh yeah, of course, if it's moving, it just keeps moving. Because they're not really thinking about, but no, something has to make it keep moving. You just can't say, oh, it has mass, therefore it just keeps moving. There's a mechanism. And Feynman did talk about that a little, and how we just don't have an explanation for it. And yeah, I'm sort of arguing that the explanation is in that kinetic understanding of photons and the speed of light, and it's all light trapped, and so then you have to sort of explain the movement. So that's where my school of fish metaphor comes in and all that kind of stuff. So anyway, but the thing I did want to talk about also was this light thing, because I was thinking about relativity and Einstein's paradoxes, or whatever they are, that are created by this relativity theory. So I'm arguing that time dilation is merely a slowing down of metabolism. As you go quicker, metabolism slows down, your atomic metabolism. That would mean the same thing as your physical metabolism, because as your atoms slow down, everything that they're doing slows down, and everything else, all the chemical reactions are all dependent on how fast atoms do their business, so everything just gets slowed down. So the clock moves slower. So when you create velocity, all you do is create a clock that ticks slower. Okay, you haven't really changed time. You've just made something that ages slower. So if you go out into space really and you shoot around really fast and you come back home, all you really did was kind of cryogenic yourself. You just aged slower. You just lived slower. Life happened to you slower. You didn't live longer. You didn't live more years. You didn't think more thoughts. You had exactly the same amount of time as they had on Earth. You just did time slower. So you wouldn't, yeah, that's all that happens. So the paradoxy stuff comes into what would happen when two bodies are communicating with each other. So one's moving very fast, one's not moving at all, and so we'll just assume that it's a rocket going past you. Okay, so it's going whatever, 3/4 the speed of light, and you're still going regular. You're just sitting here, okay, and you're going to try to communicate with the person in the rocket going very fast. Obviously, from our perspective, it's going so fast that I'm not even going to see him. But let's just say we slow it down enough that we can do that. We have instrumentality that anticipates where he's going to be beforehand, and so we say it 10 minutes before he actually gets here. So it fixes the time delay. Well, the real issue though is that what's going to happen is that everything you're doing is slower. So let's say I do have a flashlight, and I'm going to turn the flashlight on and off, just blink the flashlight, and that's our signal. Well, when I do it to him, okay, yeah, I push the button, the flashlight goes on, photons fly out the speed of light, and it all seems normal from my perspective, right? But from his perspective, looking at me, okay, what's happening from his perspective? Well, from his perspective, since I'm moving so fast, right, what's really going to happen is what he's going to see, okay, is I'm going to just, turn on this flashlight, but what's going to happen is light isn't going to come out, photons, happy little things. No, I mean, X-rays are going to come out, cosmic rays are going to come out. I'm basically going to burn him to death with the flashlight, because the incidence of the frequency of the light coming at him is going to be so much faster than his world. So from his perspective, he's going to get burned up by simple things like light. So the argument is you can never go. First off, I don't think you could ever speed matter up to anything close to those speeds without it falling apart and turning back into energy. But even if you could, yeah, the real problem would be you would be traveling through a world. Your velocity would be doubling the frequency or tripling the frequency of everything you encounter. Well, if you're going half the speed of light, you would be basically doubling the frequency. So if you were encountering, you know, 700 nanometer light, or let's say 400 nanometer light, you know, still in the visible range, it turns into 200 nanometer light. Okay, and so now you're really getting into trouble, because now, yeah, like I said, you're flying into X-rays. You're in a so well, anyway, so the point is that the light isn't going to change in terms of its ability to get from me to you. It's going to get there at the same speed, but what's going to happen is when it gets there, it's going to be at a different frequency, because it's your velocity is going to uh, it obliges that um, so I'm trying to think of it as it's going sideways past you, and you can't get fooled by that dodge, because you're still moving relative to the other party really, really slowly. Like from my perspective, you're going really fast, but you're moving slowly. See, that's the irony, right? You have very high velocity, and yet your metabolism, from my perspective, is really slow. You get it? See, so that's the complexity. So when they're receiving the light, it won't be the fact that the light is like you're running into it. So the first problem is that if you were going head on into a beam of light, it would change the frequency of that light, make it higher energy. That's one syndrome, okay? But the other syndrome is that your perception of light will be different too, just because you're moving so slow. So when I send light to you, since I seem to be going so fast, the light will also, even when it's coming sideways at you, even if you're not going head on into it, you're going to have the same problem, in that you're going to receive it so slowly. Your receiver is so slow that it's going to double the impact of it, because you won't. I don't know how to explain how that. You know, your shutter is going to move so slow that more light's going to get in, because your shutter on your camera is moving so slow. That kind of thing. So you can sort of get it from that perspective. If there was a shutter on a camera, and it was, you know, it's supposed to go click click, and only let a little bit of light in, your shutter is moving so slow it's going to let a ton of light in. So I'm just saying it's going to double the intensity of the light. And the intensity would be frequency in this circumstance. Yeah, so anyway, so none of that stuff works out as being practical in any way, but I just want to get to this point that, you know, light's being created by the metabolism of your atoms. Your atoms have metabolism, and they produce light. And as those atoms are moving faster, then they're going to produce their light slower. I mean, there's going to be more time between when they produce a photon and then when they produce the next photon, when they produce the next photon. So it's the whole redshift dilemma and all that kind of stuff is explained by this slower, not only the slower metabolism, but the fact that you'll be laying it down based on your velocity, based on how fast you're leaving the first photon. So it does matter. There is absolute velocity, and none of it's relative. So the light you produce won't be light anymore. It'll be some other kind of radiation. So you have to, like, if you want to, so my point would be, if I want to communicate with them, I have to shoot like radio waves at you, and then you might see the radio waves as light, and then vice versa for you. For me to be able to see what you're doing, you have to shoot cosmic rays or gamma rays at me, so I'll see those as visible light. So it's that kind of thing. We'd have to anticipate the distortion based on our different metabolism. So just like if we were going to speak, I'd have to highly slow down my speech for you to be able to comprehend it, and you would have to highly accelerate your speech for me to hear it. That kind of thing. Okay. But there's no space that's causing the effect. It just has to do with the metabolism of the matter itself. So the matter itself changes in terms of how it functions, but there's no space dilation. Alright, so that's one. And the other subject I wanted to play with just a little bit was this idea that there could be two explanations for velocity being maintained. One explanation might be that the shape of the atom, and that it does some sort of eccentric movement, so it wobbles through space. You could almost say that it could be like a spring, and the spring spins, and as the spring spins, it eats its way through space. But I think it's probably going to be more like some sort of imbalanced tumbling device. That this is tumbling over this, and this is tumbling around this, and it tumbles in an erratic pattern. So it doesn't spin in space because of an even centrifugal balance. And so because the balance is uneven, because it ends up bigger over here and smaller over here to its center of gravity, it just ends up tumbling through space. And so that would maintain your directionality would be that in a normal circumstance your atoms would be tumbling in many different directions. Some are going this way, some are going that way, some are going this way, tumbling in the sense of vibrating more in one direction than another direction. And they're bouncing off of each other, of course, and everything, but I mean, they have a tendency to want to go in one direction based on this tumbling mechanism. And as you gain velocity, what's happening is that more of them are tumbling in one direction. So it's a realignment of the gyroscopes of your atoms. Now, another way to maybe account for velocity, which I think is sort of interesting, but I'm not glued to it at all, is that we do have this mechanism of gravity that's creating acceleration. And you could almost think of it as like when gravity goes through you, it creates acceleration, which becomes your velocity, and that your velocity would be maintained theoretically if you didn't encounter some force to change your velocity. So if I push you in space, you just keep going. So if gravity pushed you, and if I had something that was pulling you, something gravitationally, and I just moved it, removed it, you would just keep moving as if the gravity had never been removed. At the velocity you were at, you wouldn't gain any speed, but you wouldn't lose any speed theoretically. Well, anyway, so what I was thinking is that it could be like a sail. That when gravity affects you, it changes the disposition of the atoms, electrons, or the nucleus. It might be that the nucleus is affected by gravity, and that the electron is affected in the sense that it's doing the magnetism thing, which is a form of gravity, but it's not the same. It's the B gravity. But anyway, I won't try to do. Well, I'm not saying what I will try to do. Maybe I'll feel like doing that someday, trying to model the interior of the atom. But I'm just saying that gets a little far from the general theory I'm trying to defend and support. So anyway, but the idea could be is that atoms have a kind of sail effect. So they have this directionality mechanism, but what's really happening is that it's a gravity mechanism. Like one half collects more gravity or is more susceptible to gravity than the other half. So kind of like a magnet that would be, we're back to this AB argument, but it's kind of like magnetism. But in the sense that what's happening as you're being accelerated is that this sail is essentially being put up, this gravity sail. And so the gravity pops the sail up, but once the sail's up, it'll allow it to catch gravity. So the first graviton hits it, let's say, and that pops the sail up. And now once the sail is up, the consistent flow of gravity will keep pushing it in that direction of whatever direction the sail was put up in. So if the sail was put up in this direction, then you'll move this way, and if the sail was this way, you'd move that way, and that kind of thing. So the gravity is creating a mechanism that creates a permanent gravity catcher, and that gravity catcher is knocked down if you hit a force or some other thing that is in the opposite direction. It knocks the sail down, or changes the position of the sail. So it's a way of accounting for velocity as if velocity would only exist in a place where gravity existed. material velocity, not light, but just all the matter that moves can only move if it's catching gravity, the gravity wind. So theoretically, in deep, deep space, there is no gravity, theoretically, and so there'd be nothing to sail on, and so things would lose velocity in very deep space because there'd be no sail to move them along. There'd be no wind for the sail to catch, that kind of thing. But that would be very, very far away. Yeah. So that's probably enough for this video. Yeah, that's enough. It gets a little complicated. Well, as it should, it's physics. But I don't want to get the general conceptual theory bogged down in too much nuance. I mean, I know I got to do the nuance to prove this thing to people, in a sense. You have to explain everything. But I mean, realistically, a theory of everything has got to be a diagram of everything first. You know, it's got to be a stick figure before you start putting hair on it and doing the detail. You know, and I want to get this stick figure right, and then start putting clay on it. You know what I mean? I mean, it's a process, and you know, I want to get the skeleton built before I put the flesh on, that kind of thing. But like I said, I haven't been obeying any of my own rules anyway, so we'll see what I do the next time. I do want to do the magnetism thing, because like I said, I think that is important to the atoms. I think that's where magnetism, of course, starts, with atoms. And the fact that different atoms behave differently, or magnetic versus non-magnetic materials. So it's an atomic function, and the fact that it has an expression into our world in the case of certain elements, and that's sort of insignificant. So another fact I was just thinking about, another probably fact I was thinking of, was the fact that all the elemental table of, you know, elements, periodic table of elements, is basically is like an evolution diagram, because every element has been made out of the previous kind of elements. Like every element that exists, every atom of, say, gold, was actually a hydrogen atom at one time in its existence. Or more than one hydrogen atom, obviously. It was more than one atom at some period in its existence, but it's really just, it's made of those. You could argue that all of the parts of any atom, of any element, was hydrogen at one time in its history. That no part of it was something else. It was always, it always has as a descendant a hydrogen atom. And you could almost argue that the nature of gravity might be something fundamental to a hydrogen nucleus, or to the elements of a hydrogen atom. And that's why gravity is carried through all other atoms, is because there's nothing invisible to gravity, because they all still contain that hydrogen component, so to speak, that origin component, the initial structure. You could almost argue that the skeleton of other atoms is built into that hydrogen skeleton. And hydrogen is kind of interesting, just because, you know, hydrogen doesn't necessarily have an electron, you know, which makes it kind of a weird atom. I mean, it does have a very, you get a sense of evolution. You get a sense of a parallel to evolution, in a different kind of evolution. Obviously, not a genetic evolution, not an evolution that changes a lot, or where variety happens in some fancy way. It just happens in a very crude way. So anyway, yeah, that's enough of that. So I believe I have done all I need to do here, and so until next time, see where I go. But yeah, I mean, like I said, everything I think about I'm liking it. Yeah, it's getting more and more coherent to me, and consistent and compatible. And I'm finding less and less elements that are troublesome in any kind of major way. They're just troublesome in the detail of accounting for all the movement and mechanism of a highly complex, in the sense that there's zillions of these little parts moving around, and it's very hard to keep track of the dynamic when you're trying to follow what a zillion things are doing in some sort of metaphorical way, in some sort of real-world analogy way. No, probably enough said. Okay.